On November 22, 1922, in a small farming community called Gosport, Indiana, a boy entered the world at a moment when few could have foreseen what lay ahead. His name was Eugene Morrison, though history would know him by his mother's maiden name. Born into hardship during the years just before economic devastation would sweep across America, the child arrived with nothing but a name and a future that seemed predetermined by circumstance and geography. Nobody in that quiet town could have imagined that this young man would never set foot in a college classroom, that his early working years would be spent in the factories of California installing aircraft components, or that he would eventually create the most hotly debated and universally deployed fighting rifle of the modern age. Late into the evenings, after factory shifts ended, the young machinist would sit in his Long Beach garage and move pencil across paper, sketching modifications to weapons for which he had received no formal instruction. Working through the night after leaving his position at Vega Aircraft Company, he wrestled with a challenge that had defeated military engineers for decades. The fundamental question was deceptively simple. How could a rifle be made light enough that soldiers could transport it through dense jungles and treacherous mountain terrain, yet possess enough stopping power to neutralize an enemy combatant at 500 yards, while still remaining reliable under the harshest environmental conditions imaginable? According to the experts who dominated the firearms industry, according to the officials within the United States Army Ordnance Corps, and according to military tradition extending back through the American Civil War itself, the answer seemed settled. It could not be done. A truly lightweight automatic rifle that could handle full combat loads simply did not exist in the realm of possibility. The laws of physics did not permit it. The materials available to manufacturers did not support it. Anyone claiming to have solved this puzzle was considered either foolish or dishonest. Yet this young engineer was neither. He possessed something far more valuable than credentials or industry connections. He possessed a willingness to challenge the assumptions that every other mind in the field accepted as fundamental truth. That single quality of intellectual courage would eventually equip millions of soldiers across the globe, would fundamentally alter how infantry units conducted operations, and would generate controversies that persist even now. The calendar showed 1939 when Eugene Stoner graduated from Long Beach Polytechnic High School. College education remained beyond his reach. The economic disaster of the Great Depression had consumed whatever savings his family possessed, leaving no resources for university expenses. While his classmates with greater financial advantages traveled eastward to prestigious institutions like Stanford and Berkeley, the young man simply walked through the gates of Vega Aircraft Company and requested employment. The company put him to work installing weapons systems onto training aircraft. This position demanded precision in every movement, relentless attention to detail, and a comprehensive understanding of mechanical principles and systems. Yet the work offered something that would prove far more valuable than wages. He gained direct access to aircraft-grade aluminum, a material that traditional gunmakers had never seriously considered for firearm construction. For generations, those who crafted rifles had worked exclusively with wood and steel. These materials were heavy, dense, and rooted in centuries of military tradition. They could absorb the tremendous forces released when gunpowder ignited and withstand the violent shock of recoil. This young engineer examined these materials through different eyes and perceived only constraints and inefficiencies. Steel possessed tremendous strength but carried substantial weight. Wood naturally absorbed moisture from the environment and subsequently warped, compromising accuracy and reliability. Both substances added pounds that soldiers had to transport across impossible distances. Aluminum, by contrast, the same lightweight metal that made aircraft possible, possessed entirely different characteristics. It weighed far less than steel, resisted corrosion far better than traditional materials, and when designed with proper engineering principles, proved sufficiently strong to handle all the stresses involved in rifle operation. The barrier was that no one had yet successfully created a battle-ready rifle using aluminum. Every previous attempt had failed catastrophically. Stoner absorbed this knowledge and retained it for future application. The date shifted to December 7, 1941, when the Japanese attacked Pearl Harbor. Like countless other young American men, the 19-year-old submitted his enlistment to the United States Marine Corps. choosing the specialty of aviation ordnance. The service stationed him in the South Pacific Theater and later in northern China, where he occupied his days maintaining, repairing, and servicing machine guns, rifles, and automatic weapons systems. Direct combat never found him during those war years, yet he received something equally instructive for someone destined to become a master firearms designer. He witnessed weapons fail when soldiers needed them most. He observed Marines struggling to control the M1 Garand, which was undoubtedly an excellent rifle but proved far too heavy for effective combat in dense jungle environments. He watched the M1918 Browning automatic rifle prove its power while simultaneously burdening soldiers with nearly 20 pounds of weight. He analyzed the M1941 Johnson rifle and its companion light machine gun, innovative designs that military decision-makers dismissed as excessively complicated and impractical. Every evening after completing his assigned maintenance tasks, the young Marine would spend hours sketching possible improvements and alternative designs. His notebooks filled with drawings of modifications, different approaches to gas systems, novel bolt carrier configurations. His fellow servicemen observed his apparent obsession and recognized it as genuine. By 1943, working entirely during whatever spare moments he could find, he had constructed 2 prototypes chambered in .30 caliber carbine ammunition. Neither was fully finished or tested, yet both embodied concepts that would later become central to his most influential creations. The straight-line stock design that directed recoil forces directly rearward rather than upward and outward. The streamlined gas system that eliminated the heavy reciprocating operating rods that other rifles required. The modular construction system that enabled quick field disassembly without requiring specialized tools. These were not random creative impulses. They represented systematic responses to genuine problems he had identified by watching existing combat weapons function in actual operational conditions. When August 1945 brought the war to its conclusion, the 22-year-old returned to California and immediately began seeking employment in the precision machine shop industry. He was hired to work the factory floor at Whitaker, a manufacturer producing aircraft components. Within months, his exceptional skill operating precision machinery earned him advancement to the position of design engineer. In this role, working alongside engineers who understood aerospace manufacturing methods, he developed sophisticated understanding of how to machine aircraft-grade aluminum to the exacting tolerances required for firearms manufacturing. This knowledge would eventually prove indispensable to his future work. A full decade passed as he cycled through various engineering positions while simultaneously constructing firearms prototypes in his garage during evening hours and weekends. His designs caught the attention of serious people within the firearms community, yet no major manufacturer showed willingness to commit financial resources to production. Everything changed when opportunity presented itself in an unexpected form. A startup organization named Armalite, operating as a division of Fairchild Engine and Airplane Corporation, announced they were recruiting a chief design engineer. Armalite's entire mission centered on introducing contemporary manufacturing methods and advanced materials into the traditional firearms industry. The company operated with fewer than a dozen people on staff, maintained no manufacturing facility, and functioned essentially as a research and development venture that intended to license completed designs to established manufacturers. For the self-educated engineer with unconventional credentials, it represented the perfect opportunity. He accepted the position on October 4, 1954, and immediately began work on his most ambitious undertaking to that point. The United States Army had publicly stated in 1955 that they required a replacement for the aging M1 Garand rifle. The new weapon system would fire the standard NATO 7.62mm cartridge, the same ammunition utilized by the majority of Allied nations. Military specifications demanded reliability, accuracy, and ideally, a weight reduction compared to the existing 9.5-pound Garand rifle. Every significant firearms manufacturing company operating in America and Europe submitted competitive designs. Springfield Armory contributed the T-44, which was fundamentally an M1 Garand modified to accept the newer cartridge. Fabrique Nationale of Belgium offered their FAL rifle, which already served with various European military forces. These submissions represented conventional engineering, steel receivers paired with wooden stocks, gas piston systems that had proven themselves across decades of military service. Both prototypes weighed approximately 9 pounds. The submission from Armalite received the designation AR-10, standing for Armalite Rifle Number 10. The weight specification arrived at 7.25 pounds. Army testing personnel at Springfield Armory initially suspected calculation errors in the submitted paperwork. Conventional wisdom held that no rifle-firing full-power NATO cartridges could possibly weigh so little and maintain reliable operation. They assumed the documentation contained mistakes. When the actual rifle arrived for evaluation in late 1956, testing officials confronted a weapon unlike anything they had previously encountered in military service. The stock and forward grip were manufactured from fiberglass, reinforced with foam material, techniques borrowed directly from aircraft construction methods. The receiver was forged from 7075 T6 aluminum alloy, the identical material that aircraft manufacturers used for critical structural components. The design philosophy itself was revolutionary. The stock aligned directly behind the barrel in a perfectly straight configuration, rather than dropping downward as traditional rifles had always been designed. This straight-line arrangement meant recoil energy traveled directly rearward into the shooter's shoulder, rather than creating the characteristic upward muzzle climb associated with conventional rifles. The gas system represented a complete departure from established practice. Rather than employing a heavy operating rod system similar to the M1 Garand or the piston arrangement featured in the FAL, this design channeled expanding gases directly from the barrel into an internal tube connected to the bolt carrier group. The system, commonly referred to as direct impingement, though technically classified as an internal expanding gas system, eliminated approximately 2 pounds of moving metal components. The initial evaluation reports displayed genuine enthusiasm. Testers reported that the AR-10 exhibited superior controllability during automatic fire compared to any rifle they had previously tested. The straight-line layout combined with an effective muzzle brake made the weapon manageable despite the powerful ammunition it fired. The accuracy performance proved excellent, consistently generating groups under 2 inches at 100 yards, which exceeded the performance of both competing designs. Reliability demonstrated itself adequately during early testing phases. The aluminum receiver exhibited no visible stress damage or indications of structural failure. Then the Army implemented their rigorous endurance testing protocols. Military testers subjected the rifle to conditions designed to expose any possible weaknesses. They fired thousands upon thousands of rounds without stopping to clean or perform maintenance. They exposed it to extreme temperature swings. They deliberately dunked it in mud and sand mixtures. During one particularly harsh evaluation, the composite barrel assembly, which consisted of a steel tube surrounded by an aluminum outer sleeve, failed suddenly and violently. The barrel ruptured completely, destroying the rifle in the process. The testing officials completed their report. The AR-10 was rejected. They acknowledged the innovative engineering. They recognized its lightweight advantage. They noted its excellent controllability. Yet they concluded that solving the remaining problems would require 5 years or more before the design could achieve military adoption status. The United States Army selected the T-44, which entered production as the M-14 rifle in 1957. The AR-10 had failed its crucial test. However, the designer extracted valuable lessons from this setback. The composite barrel had been a decision made by Armalite's president specifically to reduce weight, implemented despite his substantial objections. He immediately designed a replacement using conventional all-steel barrel construction for the AR-10. While the timing proved unfortunate for American military trials, the revised design opened possibilities elsewhere. In 1957, Armalite granted manufacturing rights to the AR-10 to Artillerie Inrichtingen, a Dutch arms manufacturer. Over the subsequent years, the Dutch company produced fewer than 10,000 AR-10 rifles, distributing them to Sudan, Portugal, and additional nations. Belgian paratroopers who carried the AR-10 during African colonial operations consistently praised its precision and dependability. French Foreign Legion personnel stationed in Chad who obtained examples through various procurement channels, described it as among the finest combat rifles available. The AR-10 functioned exactly as intended. It had simply arrived too late and without sufficient operational history to convince conservative American military procurement officials who remained devoted to traditional rifle designs. While Dutch production of the AR-10 continued, the Armalite engineer pursued his next design project. He had successfully demonstrated that a lightweight rifle could handle full-power ammunition without compromise. Yet military thinkers had begun questioning whether soldiers actually required such powerful cartridges. Statistical analysis of combat data from World War II and the Korean War revealed that typical infantry engagements occurred at distances below 300 yards. At those ranges, a smaller and lighter cartridge could deliver equivalent effectiveness while enabling soldiers to transport substantially more ammunition into combat. United States Continental Army Command issued formal requirements in early 1957 requesting a lightweight rifle chambered in a small-caliber, high-velocity cartridge. The solution involved scaling down the proven AR-10 design. The straight-line configuration, the internal gas system, the aluminum receiver, the quick disassembly design, all remained unchanged. Everything was proportionally reduced for a much smaller cartridge, the .223 Remington. This civilian hunting cartridge fired a small projectile weighing less than 60 grains at velocities exceeding 3,000 feet per second. The elevated velocity ensured the diminutive bullet inflicted devastating wound trauma regardless of its modest weight. The smaller cartridge allowed soldiers to carry 300 rounds instead of 140 rounds of NATO ammunition. The initial AR-15 prototype entered completion in May 1957. When equipped with a 20-round magazine, the rifle displayed a total weight of just 6 pounds, representing less than half the M14's mass. The overall length measured 39 inches compared to the M14's 44 inches. It operated in both semi-automatic and fully automatic firing modes. Preliminary testing demonstrated it could penetrate a steel military helmet at 500 yards and standard-issue infantry body armor at 300 yards. The wound ballistics produced by the small, fast-moving bullet proved exceptional. Upon striking tissue, the projectile would yaw and fragment, creating wound cavities far larger than the bullet's diameter itself. The United States Army tested the AR-15 and dismissed it. They had recently adopted the M14 rifle. They harbored no interest in evaluating another rifle design, particularly one chambered in what they considered a hunting cartridge. The Ordnance Corps, the military branch controlling weapons procurement decisions, actively opposed the new design. Some military historians suggest this opposition carried personal motivations. Armalite had previously rejected an approach from the Ordnance Corps to acquire development rights to the AR-10, fearing the military branch would simply shelve the design. The Ordnance Corps maintained long memories. They had invested institutional credibility in the M14 program. They were unwilling to acknowledge that their selection had been incorrect. Armalite attempted marketing the AR-15 to foreign military services. Several expressed genuine interest, yet American foreign aid regulations required allied nations to equip themselves with weapons compatible with American military ammunition. Since the AR-15 utilized different cartridges than the M14, potential foreign purchasers could not legally acquire it. By 1959, Armalite confronted serious financial challenges. Multiple years of development work on the AR-10 and AR-15 had generated minimal sales revenue. The company possessed no manufacturing facilities and survived entirely on licensing payments. Fairchild Engine and Airplane Corporation, which owned Armalite as a subsidiary division, chose to eliminate the financial drain. During February 1959, Armalite transferred all rights to the AR-15 design to Colt Manufacturing Company for $75,000 plus ongoing royalty payments per rifle produced. The revolutionary rifle appeared destined to join countless other firearm designs, demonstrating potential yet never achieving commercial manufacture and deployment. Colt had purchased the design rights, but they lacked a military purchaser. The Army refused to consider it. No foreign military possessed authorization to purchase it. The AR-15 seemed bound for obscurity and forgotten storage. Then, a 4th of July celebration on a Maryland farm would alter everything about the rifle's future trajectory. On July 4, 1960, Richard Boutelle, president of Fairchild Corporation and former head of Armalite, organized an Independence Day gathering at his property. General Curtis LeMay, Vice Chief of Staff of the United States Air Force, attended the event among other distinguished guests. LeMay had earned legendary status throughout American military circles. He orchestrated the devastating firebombing campaign against Japanese cities during World War II. He subsequently commanded Strategic Air Command, transforming it into the most formidable military organization ever assembled. He possessed a reputation for demanding excellence, disdaining administrative obstacles, and fighting tenaciously for initiatives he deemed essential. At 53 years old, he held the distinction of being the youngest four-star general in American military history. William Mullen, employed as a salesman for Colt, had brought an AR-15 rifle to the gathering with hopes of demonstrating the weapon to any military officers who might attend. When word reached him that General LeMay would attend, Mullen began orchestrating an elaborate presentation. He arranged watermelons at precise intervals, 50 yards out and then another 100 yards beyond that. Then he handed the AR-15 over to the general, along with several loaded magazines ready to fire. The general and experienced chutter took hold of the rifle, examined it for just a moment, then started shooting. The watermelons simply came apart. Those tiny bullets, the .223 variety, screamed downrange at speeds exceeding 3,000 feet per second. And when they found their targets, the melons burst open in spectacular fashion. LeMay continued firing through several magazines, striking watermelons at different ranges. The weapon never hesitated. When Mullen mentioned that one watermelon remained untouched, the general had a different idea entirely. "Let us eat the son of a bitch," he declared. While the demonstration went on, the general and his guests feasted on that last watermelon. But LeMay's mind was working the whole time, firing off questions. He wanted details about how the rifle was designed, what the ammunition could do, how many could be produced. The answers fascinated him. This rifle, fully loaded, weighed just 6 pounds compared to 9.5 pounds for the M14. A single soldier could carry 240 rounds of that 5.56mm ammunition instead of 100 rounds of the heavier 7.62. The shooting scores told their own story too. 43% of soldiers qualified as expert marksmen with the AR-15, while only 22% reached that level with the M14. By the time the gathering ended, General Curtis LeMay had made his decision. He wanted this rifle for the Air Force. The men protecting American air bases were still carrying the M1 carbine left over from World War II, a weapon wholly inadequate against any serious threat. The AR-15 would deliver the firepower of infantry weapons while staying light enough for security troops who needed to move quickly. He made his move right there, ordering 8,500 rifles and 8.5 million rounds of ammunition. A decision made at a 4th of July barbecue based on nothing but watermelon shooting. Then came the obstacle. The United States Army controlled all rifle purchasing for every military branch. Without Army approval, the Air Force could not have those rifles. The Army had already said no to the AR-15. They showed no interest in changing their minds, especially not because an Air Force general wanted something different. General Maxwell Taylor, the chairman of the Joint Chiefs of Staff, told President Kennedy that having two different rifle calibers throughout the military would create serious problems. LeMay's request was rejected. Yet Curtis LeMay was not someone who accepted defeat. Over the next 2 years, he would launch one of the most relentless battles in American military purchasing ever attempted. The Air Force Vice Chief of Staff filed request after formal request. He attended meeting after meeting in the Pentagon's corridors. He brought data showing the AR-15 outperformed the M14 in Air Force testing. He demonstrated that the Army's resistance came from institutional stubbornness, rather than any real factual basis. Then in summer 1961, LeMay earned his promotion to Air Force Chief of Staff, putting him at the very top of the service. From that position, he had direct lines to President Kennedy and Defense Secretary Robert McNamara. He immediately asked for approval to purchase 80,000 AR-15s for the entire Air Force. Once again, the answer came back as no. But this general had a reputation for never backing down. He submitted another request, then another one after that. Every time Army officials blocked it, they said the same things. The M-14 was better, and using two different calibers would create supply chain chaos. Lamy countered by pointing out that the Air Force already operated completely different weapons than the Army in countless categories. The argument continued through 1961 and into 1962. But then Vietnam began changing everything. American advisors sent to South Vietnam were reporting something alarming. The Viet Cong, armed with Soviet AK-47 rifles, were outmatching South Vietnamese forces carrying M1 Garlands. The AK-47 fired an intermediate round, very similar in concept to that 5.56mm cartridge the AR-15 used. It was lighter than standard NATO rifles, far easier to control when firing automatically, and devastatingly suited to jungle fighting. American advisors in the field began asking for AR-15s to test. Late in 1961, Defense Secretary McNamara authorized a trial run. Over 1,000 rifles went to Vietnam for testing by Special Forces units and South Vietnamese soldiers. The feedback came back overwhelmingly positive. Special Forces troops reported that the AR-15 was perfect for jungle combat. It was light enough to carry through dense undergrowth. It was compact enough to operate in tight spaces. The smaller cartridge meant soldiers could pack enough ammunition for long patrols without exhaustion. Yet despite its compact size, the rifle was brutally effective against enemy forces. Those high-velocity, lightweight projectiles created devastating wounds. South Vietnamese fighters who got their hands on AR-15s for evaluation refused to return them. They said the lightweight design and ease of control made it dramatically superior to everything they had been using. Some Vietnamese soldiers claimed the AR-15 gave them the fighting power of 3 men combined. Now Secretary McNamara faced two completely contradictory pictures. Army leadership insisted the M-14 was superior, and the AR-15 was unsuitable for military use. Meanwhile, the Air Force, Special Forces teams, and Vietnamese soldiers in actual combat were saying the opposite. The AR-15 was dramatically better. McNamara decided to order more testing. Early in 1962, he set up a comprehensive study that would directly pit the AR-15 against both the M-14 and the Soviet AK-47. This became known as the Hitch Report, released in summer 1962. The conclusion was devastating for the Army. The AR-15 proved superior to the M-14 across every single measurable standard. Soldiers equipped with AR-15s could carry more ammunition, hit targets with greater accuracy, and maintain their weapons more easily than soldiers carrying M-14s. The report went even further. It stated that the M-14 had failed to outperform even the AK-47. Here was America's newest rifle, adopted just 5 years before at tremendous expense, and it was inferior to the Soviet weapon it was designed to beat. The Army fought back hard. They claimed the testing was skewed. They ran their own tests claiming M-14 superiority. They argued the 5.56 cartridge did not have enough stopping power, but McNamara had already decided. In November 1962, he approved initial purchasing of the AR-15 for the Air Force and Army Special Forces. General Lamy finally got his rifles, though fewer than the 80,000 he had pushed for. His years of persistence had finally worked. The first batch of 8,500 rifles arrived in May 1962, almost 2 years after Lamy's watermelon demonstration in Maryland. The weapon now carried the designation M-16. Colt had made some design adjustments to the original AR-15, most importantly, relocating the charging handle from underneath the carrying handle to the rear of the receiver. Manufacturing started accelerating rapidly. In November 1963, McNamara ordered 104,000 rifles, 85,000 XM-16E1s for Army and Marine units, 19,000 M-16s for Air Force personnel. Colt won the contract on November 4, 1963, worth $13.5 million. By late 1963, thousands upon thousands of M-16s were rolling off production lines. By early 1964, large shipments started heading to Vietnam. Despite their doubts about the new rifle, Army leaders began replacing M14s with M16s in units shipping out to Southeast Asia. What had seemed impossible was now happening. A lightweight rifle with a small cartridge was replacing the heavy traditional rifle that military planners had declared essential. Everything looked promising. The M16 was lighter and easier to shoot. Soldiers could control it better during automatic fire. They could carry twice the ammunition. The rifle had passed every official test flawlessly. Then soldiers began coming home in body bags, and their rifles were jamming up. The reports started arriving in late 1965. M16s were failing in actual combat. The rifles refused to eject spent cartridge cases, leaving them locked inside the chamber. Soldiers were discovered dead, their rifles taken apart beside them, frantically trying to clear the jam while enemy fire poured down. Marines wrote letters describing their rifles as worthless. Some soldiers distrusted the M16 so completely they grabbed AK-47s off dead Viet Cong, willing to face court-martial if it meant carrying a rifle they could depend on. Sons sent letters home explaining how their rifles kept jamming every few shots. One Marine wrote, "We left with 72 men in our platoon and came back with 19. You know what killed most of us? Our own rifle. Nearly every single one of our dead had his M16 torn to pieces next to him where he was trying to fix it." The failure numbers were shocking. A 1967 survey found that 80% of 1,585 soldiers reported stoppages while firing. The M16, which was supposed to give American forces the edge over their enemy, had become a deadly problem. Soldiers started calling it the Mattel toy, mocking the toy company. They said it worked fine at the range, but fell apart when it mattered. Some units begged to get their old M14s back. Others hunted the battlefield for AK-47s from dead enemy fighters. Soldiers created underground trading networks, swapping cigarettes and other items for captured Soviet rifles. The weapon representing American technical skill had become a symbol of abandonment. What had happened? How had a rifle that worked perfectly under test conditions become so unreliable when soldiers' lives depended on it? Eugene Stoner was shaken by what he heard. He traveled to Vietnam early in 1967 to see for himself. What he discovered would eventually lead to a congressional investigation and expose one of the most shameful moments in American military purchasing. His rifle design was fundamentally sound, but the Army had altered it. Changes made without proper testing, without talking to the designer, without grasping the engineering that made the rifle work. Those changes had transformed a dependable weapon into something that could kill the men carrying it. The first issue was the powder. Stoner had designed the AR-15 to use IMR 4475 powder, a specific stick powder that burned relatively cleanly. All the rifles testing had used this exact powder. It created consistent pressure inside the chamber, left minimal buildup, and the rifle performed reliably every time. But the Army, without asking Colt or the designer, switched to a completely different powder. They chose WC-846 ball powder, made by Olin Matheson, a company with close ties to Army purchasing officials. This ball powder burned much dirtier than IMR powder. It left heavy residue throughout the chamber and on the bolt face. It also generated slightly higher pressure, which pushed the rifle's cyclic rate from around 750 rounds per minute to nearly 1,000. That faster cycling meant the extraction system was yanking cartridge cases from the chamber faster than the design intended. Combined with dirty powder leaving thick residue in the chamber, this created conditions perfect for failure. Spent cases would get stuck, and when the bolt tried to pull them at high speed, the case rims would snap off, leaving the case jammed inside. Clearing the jam required pushing a rod down the barrel from the muzzle to knock it out, impossible in a firefight. The second problem was the absence of something important: chrome plating. Stoner had insisted that the chamber and bore be chrome-plated to stop corrosion. Chrome plating was standard on military rifles that would see humid environments. The Vietnam jungles, saturated with moisture and lacking proper maintenance facilities, were exactly where chrome plating mattered most. Armalite had pushed for it from the start. Colt had specifically asked Army procurement officers for chrome plating, but the Army, trying to cut costs, removed that requirement. They said it was not necessary. Steel chambers corroded fast in Vietnam's humidity. Corroded chambers made extraction harder, making the stuck case problem worse. Ammunition in humid storage also corroded, the brass developing a film that increased friction. Congressional testimony later identified chrome plating as the most critical factor in M-16 failures in Vietnam. The third problem was training, or the complete lack of it. The Army had decided to market the M-16 as maintenance-free. They told soldiers the rifle did not need cleaning. No cleaning kits went to the troops, no manuals arrived. Soldiers showed up in Vietnam having fired the M-16 once or twice for basic familiarity, with zero training and maintenance, and with no tools to clean it even if they had wanted to. The rifle was not self-cleaning. No firearm cleans itself. The gas system, routing hot gases straight into the receiver, needed regular cleaning to prevent carbon accumulation. With dirty ball powder, missing chrome plating, humidity, and no maintenance training, rifles fouled quickly and stopped working. Soldiers trained on M1 Garands and M14s that could run with minimal care found themselves with rifles needing constant attention just to stay functional. One documented tragedy from the congressional investigation involved a Marine squad in heavy fighting. Only one Marine had a cleaning rod. As each rifle in the squad jammed, this Marine sprinted up and down the line, using his rod to clear each one. He was killed while trying to clear a jam for another Marine. The investigation concluded he died because the Army had refused to issue cleaning equipment. The fourth problem was the forward assist. The original AR-15 had no forward assist, no device to manually push the bolt forward if it did not close fully. The designer had excluded it deliberately. His philosophy was that if the bolt would not close by itself, something was wrong that needed fixing, not forcing. But Army ordnance officers, used to rifles with forward assists, demanded one added to the M16. The forward assist let soldiers force rounds into dirty chambers, putting more stress on extraction and making jams more likely. Tests at Rock Island Arsenal showed that forcing the bolt forward could cause serious extraction failures, but the Army ignored these results. By early 1967, the M16 disaster had become national news. Parents were writing congressmen. Newspapers printed stories about bad rifles. Soldiers were being killed not by enemy bullets, but by their own weapons failing them. On the 15th of May in 1967, a congressman from Missouri named Richard Cr. brought together a special subcommittee dedicated to investigating the M16 rifle program. What followed would stretch through late August that year, consuming months of testimony from hundreds of witnesses and ultimately producing a congressional report so scathing, so comprehensive in its condemnation, that military historians still point to it as one of the most damning indictments of American military administration ever committed to official record. Eugene Stoner took the stand before this committee. He laid bare what had happened to his creation. The Army, he explained with careful precision, had fundamentally altered his original design without ever bothering to consult him. He then demonstrated something remarkable. When the rifle was built exactly as he had specified, using IMR powder, properly applied chrome plating, and given the maintenance any quality firearm deserves, the M16 functioned with the same reliability as any combat rifle ever issued to soldiers. He produced documentation proving he had urged chrome plating from the very beginning. Test results he presented showed definitively that the weapon performed flawlessly when fed the correct ammunition. Representatives from the rifle manufacturer brought their own bombshell testimony. They had warned military decision-makers about the dangers of using ball powder in the ammunition. Their warnings had been dismissed, ignored, cast aside. They produced internal company documents demonstrating that they had specifically recommended chrome plating. That specification had been stripped away deliberately, removed from the final design not because it was inferior, but because it cost more money. Procurement officers, they testified, had pressured their engineers to accept modifications that the company's own technical staff knew would cause failures in the field. Internal corporate memoranda entered into the record shocked the committee. The manufacturer had actually predicted the extraction failures months in advance. They had foreseen these problems before a single M16 jammed in a Vietnamese jungle. Army ordnance officers then testified, and their statements were utterly damaging. Pressed under questioning, these high-ranking military officials admitted they had never adequately tested ball powder before authorizing it for ammunition production. They confessed they had failed to supply cleaning kits or maintenance instruction to troops deployed in Vietnam. They acknowledged they had promoted the rifle as self-cleaning, despite possessing no evidence whatsoever to support such a claim. Some officers even admitted their personal preference for the older M-14, suggesting their bias had influenced their decisions regarding the M-16. The subcommittee released its findings on October 19, 1967. The report stretched nearly 600 pages. Its language was extraordinary. Military mismanagement and negligence, the committee concluded, had caused the rifle's failures. The Ordnance Corps had modified the ammunition without proper testing. Essential specifications like chrome plating had been deleted to save expense. Training materials and cleaning equipment had never reached the soldiers who needed them most. Warnings from both designer and manufacturer had been disregarded. The language was unprecedented in congressional documents. The failure to correct known problems, the report stated, bordered on criminal negligence. The scandal demanded immediate correction. Chrome-plated chambers and barrels went into emergency production. The ammunition was switched back to improved powder formulations. Millions upon millions of cleaning kits were manufactured and rushed to every soldier in Vietnam. The Army created comic book-style maintenance manuals to teach soldiers how to care for their weapons. Mandatory training programs on M-16 maintenance were instituted across all units. 10 modifications were made to the rifle's design, producing what became known as the M16A1. The Ordnance Corps officially standardized this improved rifle on February 28, 1967, replacing the earlier designation. With chrome-plated chambers, proper ammunition, cleaning kits distributed to every soldier, and trained maintenance personnel in every unit, the M16A1 demonstrated exactly what Stoner had always maintained it could be. By late 1968, malfunction rates had dropped to levels matching any standard military rifle. Soldiers who received the updated weapon, along with proper training and equipment, discovered it was genuinely excellent. Light, accurate, responsive, and completely dependable, when maintained correctly with quality ammunition, it began earning respect in combat. Troops appreciated the ability to carry 300 rounds compared to only 140 rounds of the heavier M14 ammunition. The close-quarters fighting common in Vietnamese terrain suited the rifle perfectly. The small, high-velocity projectile proved devastatingly effective against enemy personnel. The M16A1 remained in service through the remainder of Vietnam and became standard issue across all American military branches. By the 1970s, Allied nations worldwide had adopted it. By the 1980s, millions had rolled off production lines globally. The design continued evolving. The M16A2 arrived in the 1980s with a heavier barrel, better rear sights, and protective elements for left-handed shooters. The M16A4 appeared in the 1990s, introducing a flat-top receiver with mounting rails for optical equipment. In 1994, the military introduced the M4 carbine, a shorter version featuring a 14.5-inch barrel and collapsible stock. This carbine gradually replaced the M16 in frontline units, becoming the primary infantry weapon. Yet both rifles maintained core principles from the original conception: the gas system, the straight-line stock, the aluminum receiver, modular construction allowing customization and repair. The breakthroughs first conceived in a Long Beach garage during the 1950s remained the fundamental foundation of America's military rifles 7 decades later. But Stoner did not stop innovating after the AR-15. In 1961, following Armalite's sale of rights, he moved to consulting work. He then joined Cadillac Gage, where between 1962 and 1963, he created the Stoner 63 weapon system. This modular design could be reconfigured as a rifle, carbine, or light machine gun, depending on mission requirements. Navy SEALs adopted the Stoner 63, and it saw limited deployment in Vietnam. Approximately 4,000 units were manufactured between 1963 and 1971. Though it demonstrated his continuing genius for innovation, it never achieved the widespread adoption that the M16 commanded. In 1971, he established ARES Incorporated in Port Clinton, Ohio. There he developed improved versions of the Stoner 63, calling them the Stoner 86. He pursued advanced concepts that were far ahead of their era. He experimented with polymer ammunition to reduce weight further. He designed telescoping cartridges that would pack more rounds into standard magazines. He worked on caseless ammunition systems. These ideas seemed too radical for the 1970s, but decades later, firearms designers in the 21st century would find inspiration in his pioneering thinking. At age 67, in 1990, Eugene Stoner joined Knight's Armament Company in Titusville, Florida. There he designed the SR-25, a larger caliber version of the AR-15, chambered for the 7.62mm NATO cartridge. The SR-25 united the precision accuracy of a sniper weapon with the reliability and handling ease that made the M-16 exceptional. The United States Navy adopted it as the Mark 11 Mod 0 sniper weapon system. Navy SEALs carried it through Iraq and Afghanistan, praising its accuracy and dependability consistently. It represented one of his final designs and one of his greatest achievements. The SR-25 proved conclusively that the fundamental AR-15 design could be successfully scaled for larger ammunition, validating theoretical work he had first explored 4 decades earlier with the AR-10. In May 1990, something extraordinary occurred. Eugene Stoner met Mikhail Kalashnikov, designer of the legendary AK-47, for the very first time. These two designers of rifles that had equipped opposing forces in virtually every major conflict since the 1960s finally encountered each other in Washington. They toured the NRA's National Firearms Museum together, studying their respective designs displayed in close proximity. They visited a shooting range in Virginia, where each fired the other's weapons. They traveled to the Marine Corps base at Quantico, observing new weapons testing. By all accounts, they became friends during those few days. Two designers who recognized they had both been solving identical problems, merely from different philosophical directions. Kalashnikov had chosen simplicity and ruggedness above all considerations. Stoner had prioritized lightweight construction and precision capability. Both had succeeded in creating weapons that would serve their respective nations for generations to come. Eugene Morrison Stoner died of cancer on April 24, 1997, at age 74. He was working on a firearms design in his Florida garage when illness finally prevented him from continuing. He was laid to rest at Quantico National Cemetery in Virginia, among the Marines he had served alongside more than half a century prior. His wife Barbara, whom he had married in 1965, survived him, along with 4 children from his first marriage, 7 grandchildren, and 4 great-grandchildren. He accumulated no significant wealth. Despite designing the most produced military rifle in American history, he never grew rich. Licensing arrangements provided modest royalties, and he spent his working life employed by companies rather than owning them. He died quietly working on problems that fascinated him, avoiding the spotlight, allowing his engineering to represent his accomplishments. The rifle he created has become the most disputed firearm in American history. More than 30 million civilian semi-automatic AR-15s now exist in American households. They have become symbols of gun rights for some Americans and symbols of gun violence for others. 10 states have enacted various restrictions and bans on AR-15-style rifles. The debates persist, passionate and unresolved. His family has publicly stated he designed the AR-15 specifically as a military weapon, never anticipating civilian applications. They believe he would have been appalled by its association with mass shooting incidents. Others counter that he would have supported civilian ownership of his design, pointing to his extensive work on civilian firearms throughout his career. The truth, like much about the man himself, likely contains more nuance than either side fully acknowledges. What remains unquestionable is the rifle's military significance. The M-16 family has equipped American soldiers in every conflict since Vietnam. American forces have carried it in Grenada, Panama, the Persian Gulf War, Somalia, Bosnia, Kosovo, Afghanistan, and Iraq. More than 18 nations have adopted it. South Korea, Singapore, and the Philippines have manufactured it under license. Countless copies and derivative designs trace their origins directly to his conception. The Taiwanese T-65, the Canadian C-7, the British L-85A1, and dozens more rifles owe their fundamental design to his work. The rifle fundamentally transformed modern infantry tactics. Before its adoption, military doctrine assumed soldiers would engage enemies at 400 to 600 yards. The M16's intermediate cartridge was optimized for engagements under 300 yards. This forced complete rethinking of infantry tactics. The result was new doctrine emphasizing rapid maneuver, suppressive fire, and quick assault techniques. Modern infantry combat, with its emphasis on speed and overwhelming firepower, became possible because of the M16's combination of lightweight construction and high rate of fire. The rifle also transformed military logistics in often overlooked ways. The 5.56mm ammunition weighed considerably less than 7.62mm NATO rounds. Soldiers could therefore carry substantially more ammunition for equal weight. Infantry units could sustain fire for extended periods between resupply. In operations conducted far from supply bases, this represented critical advantage. The M16's lightweight combined with ammunition efficiency made modern helicopter assault tactics practical. Soldiers inserted by helicopter could carry sufficient ammunition for sustained combat operations, something that had been impossible with heavier weapons and their bulky ammunition requirements. The gas system pioneered in the design became standard for modern military rifles globally. While some designers still prefer piston systems, most contemporary military rifles employ variants of the direct gas system. The simplicity, lightweight nature, and reliability when properly maintained have proven remarkably difficult to surpass. Even rifles appearing dramatically different often incorporate fundamental design principles first demonstrated in the AR-15. Eugene Stoner's story challenges many widely held assumptions about firearms design and military procurement processes. He possessed no formal engineering education beyond high school. He learned his profession in aircraft factories and machine shops. He designed weapons in his garage, not in military laboratories or government facilities. He questioned traditional assumptions that everyone else accepted as unchangeable fact. He succeeded because he dared to think differently, because he used materials others dismissed, because he challenged established experts who insisted his concepts were impossible. The Army ordnance officers who opposed his rifle possessed decades of experience. They held engineering degrees from prestigious universities. They had designed weapon systems that served in 2 world wars. They were utterly convinced that a self-educated machinist from California could not possibly possess greater knowledge about rifle design than they possessed. They were profoundly wrong. Their arrogance, their refusal to acknowledge they might be mistaken, ultimately cost American soldiers their lives in Vietnamese jungles. The M16 crisis of 1967 resulted not from flawed design. It resulted from military bureaucrats who modified the design without comprehension, who ignored warnings from both designer and manufacturer, who placed institutional pride above soldier survival. The congressional investigation concluded that officials with decision-making authority in the Army had failed to correct known deficiencies and that this failure bordered on criminal negligence. Yet despite these damning findings, accountability was absent. No one faced court-martial, no one lost command. The institutional culture that had generated the disaster remained substantially unchanged. Subsequent investigations and reforms improved military procurement procedures somewhat, but similar problems continue emerging regularly. The lesson that should have been absorbed, that innovation emerges from unexpected sources, that expertise deserves respect regardless of its origin, remains extremely difficult for large institutions to internalize. The M16's troubled service introduction stands as a cautionary tale regarding bureaucratic arrogance and the absolute necessity of listening to designers and engineers who understand the systems they create. Eugene Stoner never achieved fame comparable to Thomas Edison or Henry Ford. Most Americans owning AR-15s cannot name him. Most soldiers carrying M16s in Vietnam never learned the identity of their rifle's designer. He remained throughout his lifetime a quiet engineer, more comfortable in machine shops than corporate boardrooms. He shunned publicity. He rarely consented to interviews. His designs were his voice. When journalists did secure interviews, they encountered a soft-spoken individual far more interested in technical discussion than accepting credit for achievements. Yet his legacy cannot be dismissed. Walk through any American gun store and dozens of AR-15 variants greet you. Visit any military installation and observe soldiers training with M4s, direct descendants of his invention. Examine infantry manuals from any modern military force and discover doctrines assuming soldiers carry weapons embodying AR-15 characteristics. His rifle became the standard against which all other infantry rifles are evaluated. When nations develop new military rifles, they compare them against the M-16. When soldiers debate weapon merits, the M-16 provides the baseline for comparison. The statistics reveal unprecedented success. Approximately 8 million M16 rifles have been manufactured globally for military use. The M4 carbine derivative has been produced in additional millions. More than 30 million AR-15 rifles have been sold to American civilians, making it the most popular rifle platform in America. The design has been manufactured in more than a dozen nations. It has served in more than 100 conflicts. It has armed soldiers from more than 80 nations. It has been America's primary military rifle for over 60 years, longer than any other rifle in American military history. It shows no signs of imminent replacement. The United States Army has conducted multiple replacement programs seeking to retire the M16 and M4 in favor of new designs. All have concluded that no currently available rifle offers sufficient advantages to justify the enormous expense of transitioning to a different weapon system. The latest initiative, the Next Generation Squad Weapon Program, has produced a new rifle, but complete M4 replacement will require decades if it transpires at all. The M4 will probably remain America's primary infantry rifle for considerable time ahead. Eugene Stoner demonstrated that one individual working with determination and intelligence can change the world. He proved that formal education is unnecessary for genuine innovation. He proved that questioning accepted wisdom leads to breakthroughs experts overlook. He proved that lightweight materials and unconventional approaches succeed where traditional methods fail. He proved, though he did not live to witness it fully, that superior engineering eventually overcomes bureaucratic resistance and institutional inertia. The rifle officials declared impossible to manufacture became the rifle that defined modern infantry warfare. The machinist they dismissed as unqualified designed the weapon that experts still cannot meaningfully improve. The young man unable to afford college created technology that rewrote military history. Eugene Morrison Stoner, born in a small Indiana town during an economic depression, died having accomplished his objective. He designed and built the most effective infantry rifle humanity had ever seen. That the path from garage workshop to military standard demanded decades, congressional investigations, and innumerable obstacles only magnifies the accomplishment's significance. The rifle everyone declared impossible became, against tremendous odds and all expectations, America's rifle.